Quick footnote as you're thinking about what topic you should research this week. There's lots of tools out there. There's a lot of hardwares out there. There's a lot of softwares out there. One of the topics that you might not have a good grasp on is the data, the complexity of data. If you're thinking about it, think about it from the perspective of if I have data, how will software know what to make of that data? Because data that has been created and the data has continuously been flowing into the system, one day instead of X, Y, and Z, your name pops up. And if your name pops up, how does the system behave or react to that? And as you can think of it, it does not react very well because X, Y, and Z is what it used to, not your name necessarily. So this system input and output really gets disrupted very fast and very often. It happens a lot. It happens on an hourly basis. Now, with artificial intelligence, it happens over time. And as it happens over time, system starts to drift. And when the system or artificial intelligence starts drifting, how do you know what to correct it? Because you are so accustomed to that XYZ output, but AI never figured out that you are not part of that XYZ. Your name is not part of that XYZ. Your name was supposed to be omitted. Your name was supposed to be kept private, right? So you have think about from that layer of drift, which is exciting on day one because everything works just fine with the subject matter experts around. Everybody's able to put their 2 cents in. But 3, 4, 5 months later, when things have died down and things are just working as used to for the last 3 or 4 months, how do we start detecting that drift? So you have to be able to ask those questions ahead of time. Let's take the next step. In the first few minutes, we talked about why starting with defense changes how you understand artificial intelligence. So now I want to show you something that surprises a lot of people. You might think AI lives in models, code, or labs, and it does not. AI lives in systems. And if you touch any part of that system, you already own a piece of that risk. Here's the most important idea to carry forward today. AI is not one thing, it's a stack. That stack has 3 layers: hardware, software, and data. So let's start at the bottom. Bottom of the stack is hardware. So hardware is where AI actually runs. That could be your cloud infrastructure, on-prem servers, GPUs, edge devices, cameras, sensors, or even phones, right? So most people think hardware is just an IT concern, but from a defense perspective, hardware determines the availability, your performance, and the exposure, right? If the hardware goes down is misconfigured or is dependent on something fragile, the AI fails before it ever makes a mistake, ever makes a decision, right? So it's not about even maturity of the AI, but because you never even started maturing that AI. So now let's move on one layer up. Now, software is everything that runs on top of that hardware, right? Inside that hardware, maybe. Models, applications, workflow, automation tools, dashboards. And here's a critical defense insight. Software can behave exactly as designed and still produce the wrong outcome. Okay? So software can behave exactly as designed and still produce the wrong outcome. That is where the most organizations get caught off guard because the system is working, but the decision it produces is harmful, misleading, or unexplainable. For the third layer, data. Data is what feeds the system and what the system produces. Data is not just inputs, it is logs, feedback, outputs, decisions that gets reused later, right? Repurposed and reused. So from a defense perspective, data is where trust either accumulates or collapses. So you have biased data, incomplete data, stale data, or data used outside its original context can quietly degrade outcomes over time without triggering any alarms. One of the key defense lessons is that you cannot use old AI data to feed the AI new data, right? You have to have lots of configuration on that data. It's called data cannibalism, right? Data cannibalism is like a snake eating his own tail. You can have really good times with the first 2, 3 times, but by the fourth and fifth time, according to the researchers, information starts degrading. Your AI services starts degrading. Another key defense lesson is that most AI failures do not happen inside one layer. They happen between layers. So hardware team assumes software will handle it, software team assumes data is clean, data teams assume someone else owns the outcome. So defense thinking forces us to ask better questions at each boundary. What happens if the hardware is unavailable at critical moments? What happens if the software produces a confident answer, but it's wrong? What happens if the data reflects yesterday's reality and not today's? So real-time ETLs and things of that nature, we're very accustomed to it, but if something goes wrong, we have to be able to detect what's going wrong and at what layer. So this is why PWN-D-AI is not about turning you into an engineer. You do not need to build AI to be accountable for it. You only need to be part of the system that depends on it. If you approve budgets, define workflows, accept outputs, or act an AI-driven decision, right? You're acting based on an AI-driven decisions. You are already in the chain of responsibility, right? This chain of responsibility comes with understanding the bill of material that is included in the whole supply chain, right? So once you see AI as a stack, defense becomes really a clarity. It tells you where the risk lives, it tells you where ownership starts, and it tells you which question actually matters.